Dear students, let us start the next topic, the rules for drawing ray diagram. Rules for drawing ray diagram. Now, before going to see what are the rules used for drawing ray diagram, let us try to understand the concept that we are learned in the 9th standard, what is mean by ray diagram. Now, when we are going to consider the definition of ray diagram is a specialized pictorial representation which is used to trace the path of ray of light. Now see, what is meant by ray diagram? Ray diagram is nothing but it is a pictorial representation of which is used to trace the path of a ray of light. This is the definition of ray diagram. Now there are three laws by which we can study, we can draw a ray diagram for a convex lens. Now the first rule is when we consider this first diagram, here we find that there is a convex ray, incident ray and refracted ray. Now the first rule is that when the incident ray is parallel to the principal axis, after refraction it passes through the focus. Now when we observe carefully this diagram, here incident ray is parallel to the principal axis. After refraction it passes through the principal focus. Now second rule is that when the incident ray is passing through the focus, after refraction it is parallel to the principal axis. Once again I am going to repeat second rule. When the incident ray is passing through focus, after refraction it is parallel to the principal axis. And third rule for drawing ray diagram is that when incident ray is passing through optical center of a ray, it cannot changes its path. It cannot changes its path. It means that when the incident ray passes through the optical center of the lens, it passes without changing its path. Now here we observe that the incident ray passes through the optical center O, right? After refraction, it cannot change its path. These are the three rules for drawing the ray diagram. Now, with the help of these three rules, we are going to see how we can draw the images formed by a convex lens for different position of the object. Now, for that purpose, we are going to understand the table which is given on your page number 83. Now in page number 83 we find that in this table there are four columns. The first one is position of object, second one is the position of the image, third one is the size of the image, and fourth one is the nature of the image. Now there may be question for you in the coming exam that in that question you are given position of the object and you have to write the position of the image, size of the image or nature of the image, or you have to draw a ray diagram. When the position of the object is given, you have to find the position of the image, you have to find the size of the image, and you have to find out the nature of the image. Now here we are going to see some diagrams which are based on these 6 position of the object. Now here we are going to consider the first, when the object is placed at infinity, at that time image is produced at focus f2. Now see this diagram. Here the incident ray object is placed at infinity, so here there is no object is shown because it is placed at infinity, but after refraction the image is formed at the focus f2. Now second, when the object is placed beyond 2f1, now this distance is f1, same distance f1 to f1, 2f1, object beyond 2f1, we find that image is formed between f2 and 2f1. Image is formed between f2 and 2f1. Similarly, when we consider the object is placed at 2f1, image is formed at 2f2, which is of the same size, it is real and inverted. The fourth one is the object is placed between f1 and 2f1, image is formed beyond 2f2, which is enlarged, real and inverted. Now in this figure we can easily observe that object and its image. object is placed between F1 and 2F1, its image is formed beyond 2F2, which is real and inverted. Fifth one is object is at focus F1, image is infinity, which is highly enlarged, real and inverted. When object is placed at F1, we find that the image is formed at infinity, which is highly enlarged. Now from this diagram we can easily observe this. Now when the object is placed between F1 and O, that is optical center and F1, image is formed on the same side, which is enlarged, virtual and erect. Now in this position we find that here in all the 5 steps we find that the image is real and inverted. But here the image is enlarged, virtual and erect. These are the 6 diagram images formed by convex lenses for different position of the object. Now let us try to draw one ray diagram with the help of this chart.